everyone, so today we're going to be evaluating expressions. So let's just do a little review before we get into evaluating expressions. So in algebra, what do we call an unknown term? The answer to that is a variable, a letter or symbol that represents the unknown. So examples could be X, Y, Z. It could also be A, B, C, D, any letter, capital, lowercase. And then sometimes also Greek letters are involved. So this is the letter theta in the Greek alphabet. That really applies when you get to geometry and trigonometry, but sometimes you will see Greek letters as variables. Next question, what do we call the number in front of the variable? And hopefully everyone knows this because we've gone over this a lot. The answer to this is a coefficient, the number in front of a variable. So it is being multiplied to a variable. So every time there is a number directly in front of a variable, they're being multiplied together. So here's an example. 3x is the same as saying 3 times x. So 3 is our coefficient and x is our variable. So if we had 5y, that would mean 5 times y. If we had 3xy, that would mean 3 times x times y. So whenever they're directly written next to each other, that represents multiplication. Invisible coefficients and exponents. So let's review this for a second. Given a variable x, what is the value of the coefficient and the exponent? So think, if we don't have any coefficients, any numbers in front, we don't have any exponents, what are the coefficient and exponent? Hopefully you'll remember the answer is 1. So whenever there is no number in front of x, technically there's a little invisible 1, and whenever there's no exponent, there's technically a little invisible exponent of 1. Don't forget, if we have negative x, that means there's a negative 1 in front, but we still have that invisible exponent of 1. Okay, so an algebraic expression, to review this definition, is an expression that contains algebraic terms joined by operations. Operations meaning addition, subtraction, multiplication, and division. This does not contain an equal sign or an inequality symbol. So for today's lesson, and for what we've been doing in the past, you've never seen solve for x or solve this equation because we don't have any equal signs. So if you don't have an equal sign, you can't solve for anything. So for right now, we're just simplifying. Here's an example of an algebraic expression. We have terms, unlike terms, that are joined by these operations here. And you can see there is no equal sign, and there are no inequality symbols, such as less than, greater than, and all that stuff. Exponent, just to review again, a number that tells you how many times to multiply another number, the base in this case, to itself. Very important to understand how to evaluate exponents. So if we have b to the e power, b is our base, e is our exponent. So an example, 5 to the third power is saying 5 times itself 3 times. 5 times 5 times 5, which is 125. Please do not make the common mistake of multiplying the base and the exponent. A lot of people would write 5 to the third power is 15, which it is not. It is 5 times 5 times 5, which is 125. Okay, so let's start evaluating expressions. So if t equals 3, what is the value of t to the third power? So what we're going to do is, we know what t is equal to. We're going to take that and substitute it in for t. T is equal to 3, so I'm going to just rewrite this. And I don't want to include any variables. So remember, when we substitute, we get rid of that variable altogether. So this is what this would look like. 3, I just want to make that a little smaller. Okay. 3 to the third power, which is equal to 3 times 3 times 3, 3 times, which is equal to 27. So when we evaluate expressions, we're just taking that value and we're plugging it in we're going to substitute it into the variable. Okay, let's look at another one. Now let's evaluate 12 over t. So I'm going to do the same thing. I know what t is equal to, so I'm going to just take what it's equal to, and I'm going to substitute in for t. Now that 12 stays the same, that division sign stays the same, that fraction symbol, and we're going to just change that t to a 3. So I'm actually going to put that in a different color. And I kind of want to do that up here too, just so you see exactly what's changing. Okay, so we have 12 over 3, which is equal to, when we do that division, is equal to 4. Okay, so 12 over t is the same as 12 over 3 because we know t is equal to 3, which just gives us 4. Okay, let's take a look at another one. 6 minus t squared. So I'm going to do the same thing where I'm going to rewrite this, but instead of writing it with t, we're going to write it with 3 because that's what t is equal to. So we have 6 minus, I'm going to put 3 in a different color, squared. Now here we're going to do the order of operations first. So inside the parentheses, there's nothing we can do inside the parentheses. So then the next step is exponents. So we're going to evaluate this exponent 3 squared, which is 3 times 3, which is 9. So I'm going to rewrite this over here. 6 minus 9. Let me just fix this arrow. Okay. And then 6 minus 9 is equal to negative 3. And that's it. So all we did was take 3, plug it in for t, and then use the correct order of operations to simplify. So here's a little summary. When evaluating expressions, we, 1, substitute the value of the variables, which is what we did first for all of these examples. Then we evaluate the expression using the order of operations and apply the rules for signed numbers. So please do not forget those rules of signed numbers and the order of operations, because those two things are super important when we're doing examples like this. We're going to take a look at 2 more examples just so you can really get the hang of it. Okay, so for number 2, if x equals negative 3 and y equals 2, what is the value of 4x squared y? So like we said in our steps before, we are going to just substitute our variables in as a first step. Now I'm going to put my x in red, and I'm going to put my y in for blue. Everything else I'm going to keep black. So I have 4, and this is x squared. So we know that x is negative 3. So instead of writing x, we're going to write negative 3. And then squared. Can't forget that. And then we have y. So remember, there's little invisible multiplication symbols in here. So I'm going to use parentheses to represent that. So that means times y, which we know is 2. Okay, so all I did was take this negative 3, substitute in for x, take this 2, substitute in for y. So now let's use that order of operations. We have multiplication and we have exponents here. We have to do the exponent first. That comes first in order of operations. So I'm going to circle it here, and we're going to do negative 3 squared. So that means negative 3 times negative 3. And negative times negative is a positive. 3 times 3 is 9. So I'm going to bring that down, and then keep it in parentheses and bring everything else down. Now from here, we just have multiplication 3 times. So I'm going to multiply 3 times 4. I'm going to work from left to right. That gives us 36. I'm going to bring down that 2. 36 times 2 gives us 72. And that's our answer. So we substituted, and then we applied the order of operations. Okay, let's do one more. We have if a is equal to 4, so I'm going to circle that in red, and b is equal to negative 1, I'm going to circle that in blue. What is the value of the sum of 7a and 2 minus 4b? So I'm going to substitute 4 in for a. I'm going to substitute negative 1 in for b, and I'm going to make sure I use parentheses throughout this whole process, okay? So I have, I'm going to do that in black first. So I have 7 Now, instead of writing A, I'm going to write 4 because that's what they told me it was equal to, plus 2, still keeping that in parentheses, minus 4. And now instead of writing B, I'm going to write that -1 because that's what they told us that was equal to. Now let's use that order of operations. We're going to do what's inside the parentheses first. And then inside, we're also going to use the correct order of operations. So before we add this, we're going to have to multiply this because that comes first. 7 times 4 gives us 28. I'm going to bring everything else down. Now I'm going to add those together. 28 plus 2, that's going to give us 30. You can get rid of the parentheses at this point. Minus 4 times -1. Now before we do this subtraction, we have this multiplication. Still comes first in our order of operations. So -4 times a -1 gives us a +4. Bring down your 30. Now you can add, and your answer is 34. And that's it.